Hey guys, this is Mr. C, and in this video, we're going to be solving some proportions. So, proportion is basically when you set two ratios equal to each other, and we call that those two ratios to be in proportion. So, they're usually going to get a fraction. So in this case, we have this fraction and this fraction, and we have an x up here, and we don't know what x is right now, even though some people might be able to figure it out pretty quick. I kind of start out with the easy ones and then progress to the more difficult ones. So this would be a real easy one. And the way you do this is the time when you cross multiply. And so if you have a fraction on one side and a single fraction on the other, then you're more than welcome to cross multiply like this. And 9 times x would go here, then your equal sign, and then 12 times 3 will go here, and 12 times 3 is 36. Okay, so this time I get a one-step equation when I'm done. Divide by 9, divide by 9. Those two 9s cancel. Bring down my x, and then 36 divided by 9 is 4. If you knew that the answer was 4 right from the very beginning, then you solved it by inspection. However, some of these problems you're not going to be able to solve by inspection. You're going to have to do some work, and teachers and professors are always going to want to see some work shown and to give you credit for that. So that's the general idea. We're going to cross multiply in each one of these, and they're going to progressively get a little more complicated. So here's one, and we're going to cross multiply. If there's only one x in one of these positions, then I just like to go ahead and do that one first. And so I'm going to multiply 4x times 2. So 4x times 2, just double it, would be 8x. 24 times 5. And so if you don't know, then you're more than welcome to get a calculator or something like that if the numbers get too big. It's no big deal. And that's going to be 120. Okay, so I have 8 times some number is equal to 120. And so what I need to do now is just divide by 8 on both sides. It's a one-step equation. Those two 8s cancel because they are multiplicative inverses. And then 120 divided by 8 turns out to be 15. And so if you're in doubt of your answer or you want to check it, you're more than welcome to take the 15, plug it back in for that x, and just make sure that this fraction here is the same as this fraction over there when you simplify it. So no big deal there. And so it gets progressively a little bit more complicated when you start taking the x or the variable and adding and subtracting from it. So here we have x plus 1 over 6 is equal to 10 over 12. Now I'm going to do something a little different. I do need to multiply these two guys together, but the 12 has to be multiplied by both of these. So to make sure that I do that, I'm actually going to write out 12 times x plus 1. Now, the better I get at this, I can distribute as I go. But if I'm just now starting this for the first time, I probably want to go ahead and just write it out with these two guys being multiplied together. This one, 6 times 10, I can just go ahead and multiply those together to get 60. That's no big deal. I don't have to write 6 times 10 down here if I already know what it is. Now I need to distribute. So when I distribute now, 12 times x is 12x. 12 times 1 is 12. Oh, almost said it wrong. 12. And it is positive because there's a plus right there, and the 12 is positive also. And that's equal to 60. Okay, so now we have a two-step equation. So we need to subtract 12 on both sides. Okay, and we're going to go ahead and cancel those out because those are additive inverses. Bring down my 12x, nothing happened with it, is equal to whatever 60 minus 12 is. So I think that's going to be 48. So now I have 12 times some number is equal to 48. And again, you might already know how to solve this by just looking at it. If you divide by 12 and divide by 12, then you're going to get x is equal to, and I believe 12 goes into 48 4 times. And so x is 4. So now, let's take a look. If we plug that solution back in there for x, 4 plus 1 is 5, isn't it? Over 6. This fraction is now the same as this one. Are these now in proportion? Well, if you do your cross products, 60 and 60 you get for both of your cross products. So I know that they're in proportion. And also, 5 times 2 is 10, and 6 times 2 is 12. So I know that this fraction over here, when I plug the 4 in, is indeed equal to 10 over 12, or equivalent to 10 over 12. That tells me that 4 is the correct solution, and I'm done with that. Okay, here, instead of just a plain x, I now have a 2x. But just to show you that this is really no big deal, I'm going to go ahead and multiply these guys first because that's where the x is. So I've got 3 times 2x plus 3 is equal to 15 times 2. And I already know that's going to be 30, so I'll just write a 30 here. So now I have a choice. I could distribute. I could also divide both sides by 3 because both of these numbers are both divisible by 3. I'm going to go ahead and distribute because that's what most students are going to do, even though I probably would have divided by 3, but that's okay. 3 times 2x is 6x. 3 times positive 3 is a positive 9. It still equals 30. So here we have a two-stepper. We're going to subtract 9, and now I get 6x is equal to, now 30 take away 9 would be 21. So now I look and I say, uh-oh, if I divide by 6, I'm probably not going to get an answer that's an integer. Well, let's see. Divide by 6, and x is equal to 21 over 6. Sure enough, 6 does not go into 21 evenly, but you can divide both of those by 3. If you divide them by 3, which you should always simplify your fractions, then you will get equal to 7 over 2, and then 7 halves would be the answer that would be in the back of the book, or that'd be the answer that the teacher or professor wants you to write. So just make sure that you write your fraction, if it is a fraction, in simplest form to make everybody happy. All right, so how can this get any more difficult? Well, we can have x's on both fractions in both these ratios. So that's no big deal. Let's just choose one to start. Let's choose this. 5 times x plus 1 equals 4 times x minus 1. Again, I'm not quite comfortable yet in distributing as I go because I don't want to lose anybody, especially if they're doing this for the first time. So we now need to distribute the 5. I always start with the left side. And I'm going to get 5x plus 5 equals, and now you got the other side, distribute and distribute. And over here, we're going to get 4x minus 4. 4 times negative 1 minus 4. Now I have a multi-step equation, so I'm going to decide to subtract 4x on both sides. You can do any of the 4 movements, but I'm going to go ahead and move this one over. Those cancel. 5 take away 4 is 1, plus 5 equals negative 4. So I kind of lucked out because now I have a one-step equation. Minus 5 on both sides. Additive inverses cancel. Bring down my x. And then negative 4 take away another 5 would be actually negative 9 for that one. And again, you can plug that back in if you want, here and here, just to make sure that you're going to get 2 fractions at the very beginning that are in proportion. Let's go ahead and let's try this one now. Not much more complicated. I've got a 3 here in front of that x. I've got a 10 as a coefficient in front of that x. So I usually tend to multiply the bigger one first. So I'm going to get 10x times 2, which is going to give me 20x. And I've got 2 times 5, which is going to be plus 10. So what I did there was I went ahead and distributed as I went, and I can skip that step that I did in the last couple ones. And this just tends to make my life just a little bit easier if you can do this. Equals, let's do the same thing on the other side. 7 times 3x is 21x. And 7 times negative 4 is negative 28. So what happened now is I wound up with a 21x over here, a 20x over there. So my first instinct is to subtract the 20x on both sides. So I'm going to get a positive result over here. Bring down my 10 equals, that would be a 1x, lucky again, minus 28. Okay, so all I have to do now is just add 28 to both sides, because the whole goal here when you're solving these linear equations is to get x by itself. And so now these guys cancel. 10 plus 28 is 38 is equal to x, and then there you go. Now when you plug that 38 back in, you're going to get some big numbers, but when you do plug it back in, the left side and the right side should be equal also. So no worries there, and you can use a calculator if you need to. This can look a little differently. You could put an expression with x here and an expression with x here and have it still be linear. So let's see how this one works. Let's just try this one first. 5 times x minus 5 times 8 is 40 equals, okay, now let's do this one. 6 times x and then plus 6 times 2, which is 12. Okay, so again, my instinct is to move the 5x over. Those cancel, bring down my negative 40. And see how the subtraction turned into a negative? That's why subtraction and negative numbers are basically the same thing, just like positives and addition. So equals 1x, lucky again, plus 12. So now I have a one-step equation, minus 12, minus 12. Negative 40 take away 12 is even bigger, so I believe that's going to be negative 52 is equal to x. Where you're going to see these proportions, you're going to see them in Algebra 1. You'll see them in geometry quite a bit. You'll see them in Algebra 2. You're basically going to see these proportions in almost all of your math classes coming up. So having a good handle on these is going to really help you out. My last example is kind of like the last one, except I just put some coefficients in front of the x's. So let's try this one. Let's do this one first this time, just to see what happens. So we have 4x times 10. And if you weren't comfortable doing the distributing as you go, we could always do it this way. 10 times 4x minus 3 equals, and we can do this, 5 times 6x plus 2, like that. We can now distribute. Let's do this one first. Okay, so we're going to get 40x. Think a student ever writes 14 here? Yep, it happens. Just be careful. 10 times 3 is 30. Equals, okay, now we have to do the second one. Distribute, distribute. You know why I draw the arrows? Because that keeps me focused on what I need to do. 6 times 5 is 30. And then 5 times 2 is 10. Oop, that's a bad 0. That's okay. All right, so now I got to start moving some stuff around. So again, instinct tells me to move the 30x over on both sides. Let's get rid of it there. 40 take away 30 is 10x. Bring down my minus 30 because I didn't do anything to that. Equals, and then the plus 10 over here is just a 10. Okay, let's add 30 to both sides. Move our constant over. Bring down my 10x is equal to 30 plus 10 is 40. So now I run out of room, so I'm going to move that over here. And it looks like that's a one-step equation, so now all I have to do is divide by 10, cancel those 10s out, and x is equal to 40 divided by 10 is 4. And then there's my answer right there. So that's basically how all these proportions work. You'll see them on all of your standardized tests and in your classes. So remember to like and share. Go ahead and subscribe to my channel if you aren't already. And we will see you guys later. Bye.